All right, let's jump right in. We're going to be looking at a paper that asks a really bold question. Could a class of compounds, famous for altering consciousness, actually help heal a brain that's in the process of degenerating? And this image, wow, it just frames the entire conversation perfectly, doesn't it? Over on the left, you see a brain that's struggling with neurodegeneration. Those connections are just frayed, they're fading away. Then on the right, you've got a healthy, vibrant, well-connected brain. And right there in the middle, this huge question mark. Can psychedelics, or what the paper calls psychoplastogens, actually bridge that gap? That's the puzzle we're going to try to piece together. So before we can even talk about a potential fix, we really need to get a handle on the problem itself. What is actually going on inside a brain when it starts to degenerate? Okay, so at its very core, neurodegeneration is the slow, progressive death of our brain cells. And this isn't some abstract concept. It has really clear physical signs. We're talking about cortical atrophy. That's the literal shrinking of your brain. Then there's synapse loss, which is the breakdown of all those vital connections between your neurons. And finally, neuroinflammation. Think of it like a low-grade chronic fire that's just constantly burning inside the brain, causing damage. And here's what makes this so absolutely devastating. That loss of connections, those synapses, that's not just a side effect, it's pretty much the main event. It goes hand in hand with how severe the dementia is. The more connections you lose, the more of your cognitive function just vanishes. It's like a bustling city slowly losing its entire communication grid, one line at a time. So that brings us to a pretty radical idea. If the main problem is a loss of structure, a loss of connections, what if there's a certain class of molecules that could actually help the brain rebuild itself? And here it is, the central hypothesis, right from the paper itself. The logic is actually pretty simple, but it's incredibly powerful. Since the shrinking of the brain is what's behind so many of the symptoms, then it stands to reason that compounds that can promote the growth of those very same brain cells could be a total game changer. It's a bold claim for sure, but there's some really fascinating biology to back it up. So how in the world could these molecules actually do that? How could they rewire the brain? Well, the proposed mechanism is all about promoting something called neuroplasticity, which is just the brain's amazing ability to change, adapt, and form new connections. It all kicks off right here, at this very specific little docking station on our brain cells called the 5-HT2A receptor. And what's so important is where you find this receptor. It's all over the cortex, the exact part of the brain that gets hit the hardest by diseases like Alzheimer's. So you can think of psychedelics as a kind of master key that fits this very specific, very important lock. Now, turning that key sets off a whole biological chain reaction, and the next critical player in that chain is a protein called BDNF, or brain-derived neurotrophic factor. Honestly, the easiest way to think about it is like Miracle-Gro for your brain. It's like fertilizer. It doesn't just help your existing neurons survive, it actively encourages them to grow new branches and form brand new connections. So you can see the whole cascade right here. It's a simple three-step process. First, the psychedelic compound comes in and activates that 5-HT2A receptor. That, in turn, tells the brain to produce more of its own growth factor, BDNF. And the final result? You get the physical growth of new connections. You're actually rebuilding the very structures that were being lost. It's this clear biological path from a single molecule all the way to brain repair. But hold on, because rebuilding isn't the only potential benefit here. That's just one piece of the puzzle. There's a second major mechanism at play: the ability to calm that chronic fire inside the brain. Get this, it turns out those same 5-HT2A receptors are also found on our brain's own immune cells. So by activating them, psychedelics can act like a really powerful anti-inflammatory. They can literally shut down the production of these damaging molecules, and they might even be able to tell the brain's immune cells, the microglia, to chill out and stop being so overzealous and pruning away perfectly healthy connections. And all of this, taken together, just opens up a whole new frontier. I mean, we're not just talking about the classic psychedelics anymore. Scientists are now engineering what you could call smarter molecules. And that's creating a whole lot of new hope for treatment. And this is such a critical distinction to understand. On one side of the coin, you've got your classic psychedelics. Yes, they promote that valuable neuroplasticity we've been talking about, but they also cause hallucinations, which is a huge hurdle for widespread clinical use. But on the other side, you have the next generation, non-hallucinogenic psychoplastogens. The whole idea here is to engineer molecules that keep that therapeutic, brain-growing effect, but completely get rid of the trip. This research also shines a fascinating new light on traditional medicines like ayahuasca. What's so cool about this is that ayahuasca isn't just one single compound. It's more like a chemical cocktail. You've got DMT, which promotes that plasticity through the 5-HT2A receptor we know so well. But then you also have harmine, which works on a totally different target to promote neurogenesis, the actual birth of brand new neurons. It's like a multi-pronged therapeutic attack, all in one brew. So you can see the potential here is obviously immense. But, and this is a big but, the science is still pretty young. So what are the key unanswered questions we really need to tackle as we move forward? First up, and this one is huge, could we actually get ahead of the disease? This is the massive shift from just treating a disease to actively preventing it. I mean, could a psychoplastogen be used as a prophylactic to build up our cognitive resilience and maybe stop neurodegeneration before it ever gets a foothold? Okay, second, the really practical question of dosage. How much do you take and how often? With these compounds, more is definitely not always better. In fact, chronic long-term dosing could lead to some pretty serious side effects. So finding that perfect therapeutic window, the sweet spot, is going to be absolutely essential for both safety and for it to actually work. And finally, how do we even know if it's working? We can't just ask people how they feel. We desperately need reliable biomarkers, things like advanced brain imaging that can actually measure the density of synapses. This would let us see these structural changes happening in real time, in living people. I mean, that would be a complete revolution for clinical trials. And so that brings us right back to where we started. This image really encapsulates the entire journey. We now have solid biological reasons to believe that these kinds of molecules can promote the growth and survival of our neurons. The fundamental question has changed. It's not really a matter of if these compounds can change the brain anymore. The new question, the really hopeful and urgent question, is how. How can we best harness that amazing power to heal it?